Hello students and welcome back. So we discussed the design aspect of a full adder using two half adders. So in this video we are going to talk about the implementation. We are going to use Verilog and implement the full adder using module instantiation technique. So let us get started. So we have identified that the logic diagram of a full adder can be made using two half adders and one OR gate, and we can use module instantiation to implement this. So let us get started and implement it using Verilog now. So we are back in the same project, and here we have created a module full adder using half adder.v. There are 5 ports. A, B, C are the inputs. Sum and carry, these are my 2 outputs. So now we have two half adders here. One is half adder using case statement, one is half adder using gate level modeling, and there is one more half adder. You are free to choose any one, and you can even use two different types of half adder for making one single full adder. It is all fine. Now we will go to one of them. Double click on this and remember the order of the ports: A, B, S, C out. Okay, this is the order. You have to remember if you use method number 1, that means by ordered list. But if you are going to use the second method, that means by naming, then you need to remember the names of the ports. Okay, so it is better to keep this code also open so that we can cross check side by side. So we will come back to our main code, and before we start doing anything, we have to first set it as a top module, and we have to do the same for simulation sources as well. So go to the simulation sources, find out your full adder and set as top module. So this is the first thing which we always do. Now coming back to our code, we had seen that there were 3 signals which were used. So we are going to say wire S1, S2, S3 semicolon. Okay, so we are declaring those extra signals. Now whichever half adder you want to call, I am calling HA underscore case 1. So this is the name. Then I have to mention the instantiation. It can be like D0, X0, A0 or anything. And then I will mention that 4 variables are attached using the ordered list. So first one is A of half adder, which is connected to A of full adder. To revise that, let us have a look at the circuit diagram again. So here you can see A of half adder will go to A of full adder. B of half adder will go to B of full adder, and then sum of half adder will go to S1 and carry of half adder will go to S2. So we will now use the name method. Okay, come back and we say HA underscore gate D1, and then the important thing. First we will mention the name of our component. So that is A, B, sum, carry. So I am writing A, B, sum and carry, everything with a dot. And then inside the brackets we will mention the full adder port names. So A is connected to C in, B is connected to S1, sum is going to the final sum, and here the name is sum itself, and carry is going to another signal called S3. And then we say we need one OR gate also So we say carry or assign carry equal to S2 or S3. So that is all. We just save it, and when we save and these ports are being updated, there is an error. Let us find out where is the error. Click on these two messages, and here we see we are using in line number 32 there is a syntax error. It is saying line number 32 near. Okay, so here we need to find out that where is the error. Well, the error is in the assignment. Here we are using less than equal to sign, but we should have used only equal to. These are called blocking and non-blocking assignment. In the future videos we'll explain that, and then we will not make this mistake. So I have removed that sign and I save it, and now when it will be updated we can see 0, there is no error, and inside the full adder there are two components, case 1 and case 2. Let us generate the schematic and see that what is the output. So we go to RTL and we say schematic. Fine, the schematic is ready, and we can see there is one module half adder using case, there is another module half adder using gate level, and there is one OR gate which is having OR of these two carry and which is the final carry. So schematic is fine, but let us cross check the functionality using the simulation as well. We have run the simulation here, and now we can cross check that 0 0 0 sum is 0, carry is 0. You are going to see these signals S1, S2, S3 also in your simulation. If you don't want them, you can remove them from this view, but do not get confused by the value of S1, S2, S3. You have to just ignore them. So 0 0 0 is fine. 0 1 0 sum is 1, carry is 0. Let us check one more. 1 0 0 sum is 1, carry is 0. And here 1 0 1 sum is 0, carry is 1, and 1 1 1 sum and carry both are 1. So everything is working fine in the simulation as well. So students, now we have designed as well as implemented a full adder using module instantiation. In the next video we are going to talk about the waveform generation. We are going to talk about the behavior simulation and waveform generation. How can we generate different types of waveforms using constant and clocks? Keep learning. Thank you.